You are listening to The Vocal Technologist. Spoken tech for your ears.
Every Tuesday it feels like you have to upgrade your laptop. But for the engineers out there actually building products, it's like the entire operating system of data is upgrading itself, weekly. It's impossible to keep up. And that's really why we do Products Thursdays. We're going to try and cut through some of that noise for you. We're going to give you a direct line into the architectural choices that are defining products right now. We're going to get into the biggest shifts in enterprise data, starting way down to the GPU layer and going all the way up to corporate strategy.
Right. That's the mission. We're going to synthesize how this whole AI explosion is forcing all the traditional systems, your RDBMS, your data lakes, it's forcing them to evolve. The entire focus has shifted. It's all about efficiency, absolute data integrity, and just a new level of scale. We've kind of broken it down into 3 areas for you. First, this new intelligence layer for LLMs. Second, some of the crucial data architecture rules and gotchas. And finally, how the whole build versus buy equation is changing.
Okay, let's unpack that. I want to start at that first intersection because it's the most fascinating one to me. How do we take something as brilliant but also, as inherently probabilistic as a large language model and make it reliably talk to the super structured, super valuable corporate data that we spent decades perfecting?
Well, the foundational problem is just trust, right? And the solution really requires a separation of concerns. What we're seeing is a really rapid adoption of what's called the transactional graph-enhanced LLM framework. It's a hybrid approach. It takes a lot of inspiration from command query responsibility segregation, CQRS.
Oh, interesting. So you're splitting the reads and the writes.
Exactly. Here's how it works. The knowledge graph, it acts as this semantic intermediary, a translation layer. It's perfect for handling queries and validation.
So it handles all the reads.
It handles all the reads, but, and this is the important part, it is not allowed near the cache register. Your relational database, the RDBMS, that's what maintains transactional integrity. It is still the only source of truth for all of your writes. The knowledge graph just translates the LLM's fuzzy request into a query the RDBMS can actually trust.
That makes so much sense. You're marrying the flexibility of the LLM with the immutability of the database.
Right.
But the cost of those API calls, that's still the elephant in the room. So architecture aside, efficiency has to mean getting more out of fewer tokens. Which brings us to TOON. Now, why do we need yet another alternative to JSON? I saw the notes on this. It's a tabular, indentation-based format. Is the engineering lift really worth it?
Oh, it is. It really is for 2 huge reasons. First, LLMs just parse this indentation format way more reliably, so your accuracy goes up. But second, and this is the big one, the economics are just undeniable. TOON is so compact, it uses, 30 to 60% fewer tokens than JSON for the same data?
30 to 60%.
Yeah, that's a direct, tangible cut to your API bill. And you get a much better signal-to-noise ratio in your prompts. It's a win-win.
And speaking of cost, running those truly massive models, the trillion-parameter ones like DeepSeek V3, that used to mean a constant, just punishing upgrade cycle to the newest, most expensive GPUs.
It did, but that vendor lock-in is being architecturally attacked by Perplexity AI's open source project, TransferEngine.
TransferEngine.
Yeah, it basically eliminates the need for that next-gen GPU upgrade cycle.
Okay.
It focuses on just blindingly fast, direct GPU to GPU communication. It gets 400 gigabits per second throughput over pretty standard hardware like ConnectX-7 and AWS EFA.
So for people who aren't in the networking weeds.
Right. Think of it this way. It uses something called RDMA, which lets one GPU basically shove data directly into another GPU's memory. It completely bypasses the slow CPU.
Ah, so you're removing the bottleneck.
Completely. And that gives you incredibly high-speed inference that's portable and way, way cheaper.
That is genuinely disruptive. You're maximizing the hardware you already own. Okay, so once you have this efficient pipeline, you need governance. And now we're seeing AI being used to grade other AI, the whole LLM-as-judge concept.
Right, and the lesson there is that evaluation has to be methodical. It's not magic.
If you want a good grade, you need a clear rubric.
Exactly. That means using few-shot examples to sort of guide the grading model, breaking down complex jobs into smaller steps, and always using a structured grading rubric that forces a chain of thought process. You have to build auditability right into the evaluation itself.
Okay, let's pivot a bit from the models and the inference back to the essential plumbing. The bedrock.
Yes, let's. Because when you're operating distributed systems that can't share a single transaction boundary, correctness is everything. You absolutely have to adopt the safety principle we call the write last, read first rule.
Write last, read first.
Okay.
Break that down.
Simple. You update your auxiliary stores, your caches, your search indexes. You update those first. But you update your golden source of truth only after those other updates succeed. And then conversely, when you're reading data, you always query the golden source first to see if the record even exists before you bother checking the other references.
And that ordering?
That ordering prevents orphan records. It maintains traceability. It basically shields you from all kinds of horrible failure modes in a distributed world.
That sounds simple and, frankly, brilliant on paper.
Yeah.
But I have to imagine enforcing that across, say, Spotify's 38,000 pipelines is not trivial. Does that rule add a lot of latency, or is that safety net just worth any speed trade-off?
Oh, the safety net is absolutely worth it. The overhead is usually acceptable because the goal isn't always raw speed, it's trust. If correctness is your foundation, performance is the roof. But getting a fast roof often means you have to give something else up.
Which brings us right to the performance trade-offs in modern data lake formats. Like Iceberg. You just can't have it both ways, can you? You can't have stream order and batch order optimization without paying a huge penalty.
No, you really can't. The conflict is fundamental. Stream order is fantastic for ingestion, right? It preserves locality. But batch order is what you want for fast queries, for query locality.
And if you try to support both layouts in one Iceberg table,
you get killed on performance. You're forcing all this costly sorting and shuffling, which just hides the compute costs you were trying to get rid of in the first place.
It's that constant battle again, isn't it? Storage versus compute.
It's always an imperfect trade-off. And speaking of hidden complexity, we have to talk about a tool that seems so simple on the surface. We need to make the case against PG Vector.
Oh, this is interesting. Because it's so popular, it democratizes vector search. It's just an extension for PostgreSQL, which everyone's already running. Wait, so if you're already on Postgres, why not use it? Is this just a problem for teams at massive scale, or should the average startup be wary too?
I think even the average team that just needs reliability and, low operational friction, they should be very cautious. The index types, like IVF flat and HNSW, they require intense, expert-level manual tuning, and they are major memory hogs.
And I heard real-time inserts are a problem.
A huge problem. They create these index rebuild bottlenecks, and then when you try to use normal filters with your vector search, the Postgres query planner just struggles. You get these massive performance dips.
So the operational complexity just skyrockets.
Massively. For most teams, a dedicated vector database is honestly the simpler, more reliable path.
So if complexity is the enemy, then sometimes the answer is to just strip away features entirely to get pure speed. And that seems to be the logic behind Blobbed.
Exactly. Blobbed is all about pure, unadulterated speed. It's a single-node object store, open source, written in Rust, and it's purpose-built for one thing: maximum NVMe SSD performance.
And the numbers are pretty wild.
They are. We're talking sub-millisecond random reads and something like 15 gigabytes per second upload throughput. It's faster than Minio, faster than RocksDB.
And it does this by just not doing other things.
By purposefully skipping every non-essential feature. No S3 style listing, no distribution. This is not for your data lake. This is for ultra-low latency content serving where every single millisecond costs you money.
And seeing this stuff at real-world scale is what puts it all in context.
It does. I mean, you look at Spotify, they're managing 1.4 trillion events a day across more than 38,000 pipelines. Their whole evolution has been towards a self-service, cloud-native platform using Kubernetes operators, with privacy just built in from the start.
And then you have Klaviyo.
Right. They're managing these huge distributed machine learning workloads using Ray. And the key insight there is how they separate the job execution from the coordination. The Ray clusters do the work, but a central MySQL-backed state machine coordinates everything. That architecture ensures consistent job state and resource isolation, which is so critical when you're spanning multiple Kubernetes clusters.
Okay, let's zoom out. Let's talk strategy. Because there's a shift happening that affects every company that relies on external web data. We're calling it the Search API reset.
This is a huge move by the incumbents.
It is. Microsoft is retiring the Bing Search API, and Google is now restricting its main search API to just 10 results.
10 results per query. That's a deliberate, massive clampdown on bulk web data access.
And it forces enterprises toward the AI-mediated services inside their ecosystems, right?
It absolutely does. What this means for you, for practitioners, is that the value of your own internal high-performance retrieval layer for RN, it just went through the roof. And you're seeing newcomers like Perplexity and Parallel rush into that relevance gap. It's a huge area of focus. I mean, even working on the Vocal Technologist show, we know the speed of retrieval is now a major competitive advantage.
And all of this maneuvering, it's changing that classic economic decision we all face, build versus buy. That dilemma is now what? AI-generated versus buy.
Exactly that. An LLM can now spit out a simple business tool, a basic automation, an internal app. It can do it in minutes, and that generative capability is just eroding vendor moats that used to rely only on having more features.
So what are the new moats? What's actually defensible now?
It's shifting completely. It's not about features anymore. It has to be proprietary data, massive network effects, crazy regulatory barriers, or just truly deep customer relationships that an AI can't just replicate. If an LLM can generate 80% of what a user needs, that last 20% of a vendor's complexity is suddenly not worth the premium anymore.
And the cost of not modernizing, the human cost, is just, it's staggering. I saw a survey that highlighted this. Data teams are losing over $21,000 per analyst per year because of inefficient processes.
$20,613.
And less than a quarter of an analyst's time is actually spent on analysis. That is just a staggering amount of lost productivity.
That 21 grand isn't being spent on creating business value. It's being spent waiting for data lineage to be traced or debugging a bad join. And addressing that requires a more advanced approach to quality, what some are calling the cybernetics of data quality.
Cybernetics? That sounds a little academic. What does that actually mean for an engineering team on the ground?
Think of it like automated, intelligent course correction for your data. It treats your whole data ecosystem as an adaptive, self-regulating system that uses real-time feedback loops to fix itself, not just, static checks on old data. The key parts are things like dynamic reconciliation engines, embedded business glossaries for semantic consistency, and comprehensive data lineage.
And that lineage is what you need for AI governance.
It's the critical piece. Because if you can't trace the cause and effect in your data, you have absolutely no hope of governing your LLM's output.
So this entire conversation just confirms one thing for me. Data architecture today is defined by a series of really high-stakes trade-offs you're constantly choosing. Storage versus compute, complexity versus convenience, stream versus batch optimization. And every one of those choices directly hits your product's performance and, more importantly, your budget.
Absolutely, and you can see that tension reflected all the way down at the hardware layer. A recent survey on the state of containers showed this rapid growth in GPU adoption. It's in about 6% of organizations now. That's 3 times the instance hours of just 2 years ago. And at the same time, you're seeing this parallel rise of high-density ARM-based platforms.
So all this investment in specialized hardware.
And yet, and this is the kicker, the survey also revealed massive over-provisioning. Most containers are using under 50% of their allocated memory and under 25% of their allocated CPU.
That is a colossal amount of waste just sitting there on the cloud bill.
It is, and it raises a really important question for you, the listener. Given the incredible efficiency gains we just talked about, things like TransferEngine, maximizing the GPUs you already have, and given this widespread over-provisioning of compute, will the economic focus shift? Will maximizing compute density rather than just minimizing storage costs soon become the single biggest driver of enterprise cloud architecture? What are you currently over-provisioning in your systems that AI is about to make cheap, fast, and dense?
Spoken Tech for your ears.